Okay, so hi everyone. Thank you to be here. We are glad to be here. We are gonna give a talk about linters, what they are, how they work, and what can they do for you. Before starting this presentation, let's introduce a bit ourselves.
Thank you. Hello, everyone. I'm Gabriel. I'm a technical lead at OVH Cloud. We're in a development team. I work with Sébastien, and we basically plug parts of the information system that usually don't talk to each other. So we work with a bunch of weird and not so weird HTTP APIs, Kafka Event Bus, things like that.
And I'm Sébastien. I work as a software engineer at OVH Cloud in the same team as Gabriel. And please accept my apologies for my French accent and my English level, by the way. And also, I have a slight stutter, so don't be surprised about it. Okay, so let's start it with the linters. But before, let's tell you a story. This is a story of a software engineer. He is young, he is happy, he is enthusiastic, and he is joining a new team. Joining this new team, he is starting to figure out some things and discovering new stuff, and he discovers the code bases of this team. So if he finds some real stuff, like error not managed, so here you can see the function and the return error value isn't checked. Big nesting, oops, huge functions or just weird code. So no, he's not so happy now. He's starting to be sad, very sad. The first thing he's thinking about is everything works, but nothing is coherent. We need rules. We need shared conventions. Okay, and here comes the linters to the rescue. What is a linter? And before to explain what a linter really is, let's start with a small analogy. Let's say you are trying to write an English sentence using your favorite software, Word, and Word will help you for sure to detect and fix the syntax errors. And now your English sentence will be syntactically valid. But that doesn't mean it's the best way to write it. Maybe it could be simplified, maybe it could be just more natural. So maybe you would want to use any software to make it more natural, like Grammarly, for example, and then your sentence will be simplified. Following this analogy, if now you are not trying to write an English sentence but source code, Word will be the compiler and Grammarly will be the linter. So it's a literary analogy, but maybe now you can start to understand what a linter could be. In few words, linters help you to detect inconsistencies, and prevent error even before they are committed. It creates a language within the programming language itself, allowing us to have a language within the team, and that helps a lot for the team communication. It can also help you for the security, the performance, etc. So a linter is your best friend. Linters are widely used, and they are commonly linters used in most of the popular language, like Python, JavaScript, Java, C, C++, and of course Go. And an interesting thing in Go is that we don't have only linters, but we also have what we call linters runners. And a linter runner is a tool that will allow you to package and manipulate easily the linters to make them configurable, etc. So it's a very convenient tool. The most used one is lint. This is the one we will use for the rest of this presentation. So let's show a small example of what you can do and what lint can do for you with this kind of linters. Let's say you are this small sample of code. So here you have a code to process something. It's not so hard to understand. First, you are trying to fetch some data from a database. Here, a user, and then you're doing some checks about this return value, and then you return it, and that's all. This is the example I showed you earlier, because here you can see that the error is returned, but not used, not checked, not managed, so that can lead to some issues, and you can have some hard time troubleshooting if an issue occurs. So, of course, we have a linter for that, error check, and an error check will tell you literally, hey dude, you have an error, you didn't even check it, please do it, and thanks that the linter isn't happy, you can prevent this error even before it's committed. But let's say another developer figured it out and thought about manage the error, it's done. This function now seems to be correct, and in my opinion it is, but one good practice in Go is to say when we export a function, it should be commented for the code readability. We have linter for that, so the linter will tell you, okay, please comment this function. It's exported, or just unexport it if it's not necessary. So okay, let's comment it. So now the function is commented, but this developer didn't thought about everything, but he managed to compare a Boolean value a weird way. So of course this can be simplified. We have a linter for that. So the thing I want to tell you with that is linters can help you in very diverse ways, and you can prevent errors. But it's not only for your code to work. It's also to improve readability, to simplify it, etc. We have many needs covered by the linters. So that's very cool. And another cool thing is, of course, you can configure a linter a very complex way to have to match your specific needs. But if you want to have minimal needs like this ones, it's very easy to set up like this small configuration file. It's enable, and it's just in 3 parts. How the linter runs. So here, for example, the timeout. Which linters are packaged in the linter runner, and which linter will use, and how the results are handled. So it's very easy. And trust me, it's very easy, but I'm not asking you to trust me by my words. Please allow Gabriel to show you from a demonstration.
Hey. So, can you hear me? Perfect. So I'm going to start with a very simple code base. Like, for example, it just has a Go mode, so I've just run the Go init command. And we'll go through this code base step by step together. I won't be live coding because I'm really afraid of that. So I've prepared a series of commits that I'll present. Oh, sorry, you see the screen.
Oh.
Yeah, that's better. Cool. So at the moment we just have the single Go mode file, but we will start with our sample project. So our project is really simple. Can everybody, especially in the back, read the code? I should increase the font, yeah? Let's try that. Better? Cool. So we have a very simple main function. It's 3 lines. We open a file, we read the file into memory, and we print the contents of the file. The file says hello world. So when we run this, I have a simple make file. we're expected to see hello world on the console. Make, run, yeah, hello world. It's at the bottom. Our IDE helps us, but let's ask the linter to help us as well. So in the next step, I've added 2 targets to my makefile. One to install the linter. It's the instructions from the documentation of Golang CI-lint, so just copied the curl, and I can run it like this, but I prefer to package it in a makefile, so I don't have to remember the command because I am lazy. So let's run this. And it already says that this import has been deprecated since Go 1.19, blah, blah, blah. And we can simplify the code. So let's do just that. It pointed us to the right direction. It says that the package IO or OS contain the same functionality as IO util. So after checking the documentation, yeah, there is a function in the OS package that reads the file into memory directly. So I've simplified my code. The linter is happy. Let's go, right? And it still runs, of course. But we see that there is a potential for an error here that is not checked. So let's configure the linter. Error check is the error linter that Sébastien presented earlier. It's enabled by default in Golang CI-lint. It's one of the few linters that's enabled by default. And by default, it doesn't check for this specific issue. So we can ask it to. We can configure, like apply a setting to our linter, ask it to check the blank errors. And now, if I run the lint command again, sorry, it says that the error return value of OS read file is not checked. So we can do that. And now the error value is checked. Cool. Does it still run? Yes. Is the linter happy? Yes. Cool. So I said that error check was one of the few linters enabled by default. We can enable more linters, and we are doing that. I've added here another linter. I've enabled WSL. It stands for white space lines, maybe. And I've asked Golang CI-lint to auto-fix the issues it finds, because that's one of the things it can do, and it's really helpful. So now I can run the linter again, and it added a white space here, because WSL is quite opinionated about white spaces, and it asks you to put white space after an if block. I think it would complain also if I had a white space here. No, okay. Well, it's a bit picky, you can configure it, stuff like that. Oops. So let me... Yeah, if I can type, that would be better, right? Cool. So we added our white space, and that concludes our first demonstration. So we saw that we can add a linter to our project without any configuration. The first thing I ran was Golang CI-lint without any config file. It runs with a few linters enabled. We can configure these linters. We can enable more, and we can ask Golang CI-lint to do the dirty work for us and auto-fix linters that have provided this functionality. Back to you, Seb.
Yes.
Let me... Where were we? Here.
Yeah. And oh, yeah, perfect. Thank you, Gabriel. Sorry. Thank you. And so Gabriel just showed you how easy it is to set up a linter in your code, and also just an advice. It's really easy to implement it as well in your CI/CD pipeline. Let's say you have this typical simple CI/CD pipeline where you want first to build test, unit test, then integration test and the following deployments. And here you are saying the two first step, the build and the unit test are mandatory for the second steps. You may want to say, okay, now the build and the unit test aren't enough to validate the code. I also want all of the linter I configured to be happy. You can just add it, and then now you can, and I think you should add the linters to your CI/CD pipeline. So we'll just implement this, but it's good to know. Now I just told you how the linters are cool, but I don't like to tell how cool the things are without talking about limitation and point of attention. So please remember that linters don't replace your code reviews and unit test. So be careful, because if you are enabling all of the linters of the universe, maybe you will have for sure more linter errors than a line of code in your code base. So be careful. Don't remember also that a linter is still a syntax validation of your code. So it acts in a syntactically way. So it doesn't have a contextual understanding, and it's limited to the defined role. What I want to say, because it's the most interesting part in my point of view, what I want to mean by that is that your needs are only covered by the existing linters. If you have a new need not covered by any existing linter, then you can't do anything. You can't lint it, or maybe not. Of course not. But to tell you it a more simple way, let me tell you a story. Once upon a time, in a small developer team at OVH Cloud, something happened. Something terrible happened. Our story, like all of the story, begins with a Kafka event bus and a microservice developed in Go. I love the story when I was a kid. So we have a Kafka event bus, and we have a microservice in Go consuming and processing this message. And the thing is, the microservice, after consuming every message, can process this message in a very short time. So here, 2 milliseconds. So it's very fast, and it's very okay for us. So the microservice is running for minutes, hours, days, and a few days later, we are starting to noticing something weird. The processing time starts to increase a bit. A lot. Whoa, what's happening? What the hell? Oh, no, our processing time is to 5 minutes and even more. The same message and the same processing that took only 2 milliseconds before now takes 5 minutes. What happened? Let's dig into the code a bit. Don't worry, it's not a conference about troubleshooting, but it will be short. So here is the code that consume and process the message. So you have the consuming loop, and the first thing we do is to add a request ID from the message value to our context in order to log it. Okay, so we want to use it, and also we also had a key value in the context before we want to use as well for our logging. So we do that, and we do this affectation at every iteration. But I'm lying a bit because it's not literally an affectation. As you can see, we use the context twice and we affect it. So we don't affect. We add a layer. We wrap the context in another layer to add the key value. Maybe you are starting to figure out what's wrong now. And if we represent it a more visual way, we have our empty context, our first key value defined before the consume loop, and then the request ID definition in the next layer. And the way we did it, we just have one layer, one additional layer for every iteration. So I let you imagine what it will look like after days and days of running. And as we need the context ID and the foobar, the first key value, that means that every time we want to do a simple logging, we will have to unstack every layer of this context, and this becomes a very big issue in terms of performance. When Gabriel figured it out, he called that the fat context issue, and it can be corrected in a very simple way. Sorry, I forgot to show that, but yeah, that's exactly what I told. So at every iteration, a new context wrap is the other one. And why? Why? Because we did a mistake in our operation. We used the affectation operation, even though we could use the definition operation. And now, if we do that, the context will be defined again at every loop iteration. So we'll ensure that we'll always have two layers, one for the first one, the foobar, and another one for the context, the request ID. Sorry. Something interesting about it is that requires several hours or maybe days of troubleshooting. The impact was not small, and it could be fixed with just one character. That could typically be the job of a linter to detect that, and of course it could be. But after doing some researches, no linter existed before to do that. That's why Gabriel took things in his hands and decided to write his own linter for this fast context issue. And I think it's a very good way to show you how to write a linter and how a linter really works in theory. But before to show you that, maybe you need to know some prerequisites. So I'll let Gabriel explain you that.
Thanks. So we are going to have a bit of theory around the code structure, how it looks, what it looks like in the compiler, and things like that. I believe there were other talks and workshops that may go way deeper into this than what we'll do on stage here. I'm no expert, but it's just to introduce the concepts that we'll need for the demonstration. So, if we have this simple statement in Go, well, it's in your source code, Go will need to convert this to a more abstract representation, and usually the term for this is abstract syntax trees, or ASTs. And every source code will be converted to this AST. So the larger your source code, the larger the tree. And a tree is like something with nodes and leaves with links between them, as this. So this is an assign statement in Go. And we assign the variable A we assign the constant value 2 to the variable A. If we take another example, a bit more complex, we assign the value A minus B with the binary operator minus to the variable A. Okay? So this is like I think every language does this, at least Go does this, Python does this. And in Go, they are specific terms. So we will be looking at for loops because that's what is our interest here. We want to detect fat contexts in for loops. So we have the for loop, the body of the for loop, which is of type block. Inside this block, there is a list of statements, And in this case, there is only one statement, which is an assign. This assign statement has a left-hand side value of the variable a and a right-hand side value, which is the constant 2. And the token is defined because we use the walrus operator, colon equal. Another example, slightly different, but not too much. We are in another type of for loop. It's a range loop. It's basically all the for loops with the keyword range. We range over what? We range over 5. And this time the token is not defined, it's assign. Because we are not defining a new variable, we're assigning a value to an existing variable. Okay? Cool. So, let's demonstrate our issue. So I take the same code base as earlier. I just replace the main file with perfect, it fits. Awesome. So we are starting a timer, and at the end we will print the time it took to run the 10,000 iterations. We create an empty context. We add a value to this context, and in every loop we are wrapping the context with another value, and we are trying to get the first value. Okay, so it's the example that we showed earlier. If I run this, it takes 240 milliseconds. Not bad, but I have the feeling that it's a bit too slow for this. If I try to multiply this by 2, we should expect a value between 400 or 500 milliseconds, if there were no issue. We see 900 milliseconds, so 4 times slower, but we only increase the number of operations we do by 2, so there must be something going on. If I multiply it again by 2, I should see something around maybe 800 milliseconds, but we'll see that it's more like, more like 2 seconds or 4 seconds. Yeah, so there's something fishy here. The issue, as we demonstrated earlier, is that we're assigning here instead of defining. If I just, if I run this with just a colon here, we see that it's much, much faster by an order of magnitude. We're talking microseconds here instead of milliseconds before. So the fix is simple indeed. What we're going to do is we're going to create a linter to detect this specific issue. We're going to detect contexts that are wrapped inside a loop that could end up being too fat and leading to these performance issues. So, the structure of a linter can be quite simple. We are defining an analyzer. We tell it it's from the package /x/tools go analysis. We give it a name, a bit of documentation, and we tell it to run this specific function that currently does nothing. And of course, we want to test things because we ended up like this because maybe we didn't test it enough. So we want to ensure that our linters does its job. And the analysis package also provides utilities to do that. So we are basically here getting a test folder, which is the sample project that we saw just earlier, and we give it we give the analysis test package our test data, our analyzer, and we tell it to run on all files. And in the test data, we can add special comments here, and they will act as tests. So on every line of code will be checked with the linter. And if the linter reports an issue with this message, then the test will be OK. If the linter reports an issue on a line that doesn't have a comment, it will be a test failure. If the linter doesn't report an issue on a line with the comment, it will also be a test failure. So basically, in this file, all 21 lines are test cases. So I run the tests and the test complaints because on this line, we didn't emit the proper diagnostic. So let's do that. Let's diagnose our code. So I've enriched a bit our function. Now it takes it does things, not much yet, but it does things. We are taking the result of a previous analyzer, which we've required here. Analyzers can be chained together to benefit from the results of an earlier analysis. It's especially interesting in Golang CI-lint because as it will run a lot of linters, it can run this only once, and then every other linter can benefit from the analysis, and it will run basically faster than if you run all the tools separately, one by one. We take this inspector. It will help us filter the nodes that we're not interested in, the AST nodes. And in this case, we're only interested in range statements because this is a range loop, as we saw earlier. It's a for loop, but of type range, because there's the range keyword. And the pre-order function basically will loop through all the AST nodes with the type that we are asking, and we're asking for the range statement. So for now, we don't do anything. Let's do something inside this analysis. So we know that what we want is to analyze the body, the statements in the body of the for loop. So we get the body here. I'm using a switch type statement because I kind of know that in the future I will want to handle another type of AST node, but we could do just a simple typecast. And I pass it to a function that currently does nothing either. So let's change that. In this function, we will loop through all the statements of the list in the body. Okay, so the body is this, and there is a list of statements. The first is this one, the second is this one. So we are iterating through all the statements in the loop, and we're only looking for assigned statements because function calls, not interested. Well, we're only interested in variable assignments. So if we don't have an assignment, we continue. We're not interested in this node. Now we're only interested in assignments that are to a value of type context. So we get the left-hand side of the assignment. So this is an assignment. Right-hand side here, left-hand side here. So we get this item, this part of the AST, and we check its type. If it's not a context, we're not interested. We don't want to check for all the assignments being int, floats, or whatever. And we're nearly there. Now we want to consider that if there is a definition, so not a strict assignment, this is an assignment, this is a definition. If we have a definition, then we are good, right? Because we don't have the issue. So if we have an assignment to a context in the loop, we can stop parsing the loop here. We won't need to check the other context below. And finally, we've caught our issue, and we can now report the issue using the analysis pass. And we can emit a diagnostic. We need to specify a position, which is the position of the assigned statement. The position is basically where in the code is the issue, and a message. And now we should be able to run the tests again. and the test pass. So cool, we've created our first linter. Awesome, right? But maybe it has an issue. What if I don't use a range loop, but I use a more classical for loop with this structure, like I equals 0, blah, blah, blah. Let's check. We have an issue on this line. So our linter didn't report the issue on this line, but why? Because, as we said earlier, we're only interested for now in the range statements. So our linter doesn't even see this loop because it's not a range loop, it's a for loop. Because GoAST, they made their choices. So we don't have much to do. We ask the inspector to also go through the for statements in addition to the range statements. And we get the body of the for statement, which is of the same type as the body of the range statement. It's a block statement. And we give it also to the process body function, which doesn't need to change. And we run our tests, and our tests pass. So cool. We created a linter in, 70 lines of code with tests. Not bad, right? Make it, oh yeah. And so now we have something that we can run in tests, but not yet very useful. We can very easily, so it's a main function with one line of code, not too bad. We can very easily create an executable from this linter, thanks again to the GoAnalysis package. We give it our analyzer, and it will handle all the heavy lifting. So we can, I think I created, we can build this. Cool, so now we've got our executable here. And we give it the sample projects. Like that, no. Oh, sorry, ./sample project maybe. Cool, and it correctly reports that there are two issues in this code, one here and one here. We could also quite easily add a way for the linter to fix this issue. I won't show it here because it goes a bit beyond the scope of the demonstration, but you can already detect that you have an issue, and then fixing it is quite easy at this point. So yeah, this concludes this second demonstration. I hope you learned something. And back to you again.
Yeah. Alors, encore toi.
Ah non, c'est encore à moi. Cool, it's me again, sorry. Is it? Oh yeah. I didn't have to go through all the slides again. So, as we can see, I'll change the mic. Cool. Yeah, as we can see on this graph, we run a benchmark between the fat context and the shadowed version, like the one where you redefine the context every time in a loop. On the x-axis, you see the number of times we go through the loop, and on the y-axis, you see the time each iteration takes in nanoseconds. So it's not the complete program, it's every iteration takes, for example, here, sorry, Seb. For example, yeah, about here, we are at 10,000 nanoseconds. So at 2,000 iteration, each iteration takes 10,000 nanoseconds, which is 10 microseconds. It's 10 microseconds just to retrieve one value from a context. If you're like us using context to log things, that's 10 microseconds to retrieve one value to emit one log line. So it's really a pain. And all these spikes that you can see on the blue line and on the green lines are the garbage collection that happens and that stops the world. So it takes a bit more time at every loop to process. And so we found this issue and we submitted a pull request to Golang CI lint. We created the linter. It's available on GitHub. It's called Fat Context. And it's available in Golang CI lint as of version 1.58, I think. So yeah, the guy who managed the Golang CI lint project is also French. He's been really helpful in the pull request and in the comments. So if you do ever create a linter, I encourage you to share it also and make it available to the community by adding it to Golang CI lint if the maintainer accepts it. And that's all.
Yeah, that's all for this talk. So thank you. I hope you enjoyed it. Thank you, Gofakin, for the invitation. Right?
Oh yeah.
And also, we'll be there to the after party. So if you want to talk with us about this talk or anything else, don't hesitate. We'll be here and it will be a pleasure for us. Thank you. So you'll see our contacts here. Yeah. So we both have a technical blog. Gabriel wrote two blog posts about this talk, so don't hesitate to read it. Don't hesitate also to scan this QR code at the top right corner for the feedback, and be nice, please. No, do as you want. It will help us. It's our first time doing this talk, so it will help us a lot to improve it. Thank you again, and if you have any questions, don't hesitate.
Thank you. Yeah, just one note. The feedback form is like 5 seconds to complete. You have stamps that you can put on things that you liked or didn't, and it would really help us. So, please.
The special command that you guys had in the code, is that something that you guys had to implement to check for that specific command? Or is it part of the package that you're using?
Okay, so the question was the special command here.
Yeah.
Is it something that we had to implement, or was it part of the package we use? It's part of the package we use. Of this package. It's all provided by the GoAnalysis package. So we didn't do anything special, and most linters, at least in Golang CI lint, are implemented using this package. So it's quite common.
Does it also prevent when you have under the branch, for example, if or something which goes deeper, in the structure, does it cause a problem for the analyzer, or is it all flattened when we are going through the list of the items that we are checking?
So the question is, sorry, let me find the main. If there are things nested deeper in the for loop, like in an if statement or another for loop inside the first for loop, or some struct, okay, will the linter be able to detect it? In this form, no. It's this implementation is very simple. It only looks at top level statements in the for loop, but you can configure it to recurse. Well, you can code it to recurse into statements, and that's what I did in Fat Context. So if you go check out the source code for Fat Context now, it's much more complex than the 70 lines of code that we just wrote, and it handles these kind of things. Thank you. There was a question, yeah?
I was curious, what are some of the limitations of the analysis package, and if you see more like something for simple linters, or if it can be used for more complex static analysis?
What, do we see limitations with the GoAnalysis package? Can it be used for more complex linters, or is it just for more simple stuff? I have not yet encountered any limitation, because what you do is go through the AST. So the analysis package won't help you with the specifics of the AST because you have a lot of type casting, type checking all around the code base if you're writing a linter. Because it's all interfaces, so you have to type assert basically. And as I said earlier, most linters, if not all linters in Golang CI lint, are implemented using this package, the Go analysis package. And I believe there are some that are quite complex, though I can't get them from the top of from memory, but it can be used for complex stuff.
I think in the example that you showed, your linter would stop on the first context definition, right? So in the PR that you actually wrote in the Golang CI, did you also implement it this way, or did you actually look for all the context assignments inside of the loop? Right? Like if there was a definition in the first place in the context, you should still loop through to see if there is an assignment to a different context, maybe.
That's a good catch. I think that we don't do that, and I think that could be an issue that you could report on GitHub. Yeah, I think we only support basically we only support one context in the loop. I've not encountered that many times where you need more than one context, but it can happen, so yeah, good catch, thanks.
Would it not be more simple to just use a different name for the context inside the loop? Because you're still shadowing the...
You could like call your context context2, and in this case the compiler would force you to create the variable.
Yeah, I'm just asking because it's much more simpler to name it something less confusing.
Depends. Yeah, sure.
Probably caged by another linter, right?
Maybe. Yeah, it's just that CTX is quite a common name for a context, so. Thank you all.
Thank you, everyone.